All right, hello Algebra 2 students. Today I'm going to be doing this video for our notes on this snowy, icy e-learning day. We're doing section 7. This is the last section of this chapter that we'll be covering for the test. Remember, your test is a two-part test on Monday and Tuesday of next week. Friday, tomorrow, will be review, so you'll have a chance in class to ask questions if you have any, but please email me as soon as you have questions. If you do today, I'll be by a computer at least till 3 o'clock to help you out. So today we're going to be doing a lot of graphing quadratics and also some completing the square. So it's kind of somewhere in between those two, or really the two mixed together, completing the square and graphing quadratics. So what we're going to learn is a new form of writing the equation of a parabola, and it's called vertex form. Okay, so vertex form is this right here. F of x is equal to a times the quantity x minus h squared plus k. And in this, the vertex is the ordered pair h, k. H right here is the x-coordinate, and k right here is the y-coordinate. This is very similar to what we did when we were graphing our absolute value equations. Just now, rather than a V, it's going to be that parabola U shape. Just like when we were doing our absolute values, remember this H right here, because of the negative sign in front of it, the H for our vertex is going to have the opposite of what it looks like. Okay, so if you see something that says x minus 3, that means h is 3. So the x-coordinate would be 3. Even though you see a minus 3, it's 3. If you saw x plus 5, it would have been x minus negative is how you got plus. So it would be a negative 5. The h, the x-coordinate of the vertex, is always going to be the opposite of what you see in here, because the way it works out in our equation is with a minus. Again, the way that we're going to be getting this is through a modified method of completing the square. And once we have it in this form, it's going to be very easy to graph. When I graph quadratics, I always graph them with this method right here, because it's just so quick and easy once it's in that form. So, quick review, completing the square. Completing the square was that three-step process of b over 2. Step 2 was to square that, whatever you got, and then step 3 was to add to both sides. Okay, so that was our regular completing the square process from before. Here, we're going to be doing it again, slightly modified. When we're trying to get something into vertex form, we are only going to be looking at this ax squared plus bx part. That plus 4, I'm just going to leave it off to the side for the beginning. So I'm just going to write y equals x squared minus 2x, leave a bunch of room, and write my plus 4 there. So just looking at this part, the ax squared plus bx, we're going to go through this completing the square process. My b in this case is negative 2, so I do negative 2 over 2, which is negative 1, and then I square that answer and I get 1. Okay. With regular completing the square, we would now add 1 to both sides of the equation. So I'm going to add 1 over here, but the problem is, in order to be able to graph this equation, I need it to just be y equals by itself. I don't want a y plus 1 over here. But let's think, if I had added 1 to this side, add 1 to both sides, if I need to get y by itself, what can I do? Well, I can subtract 1 from this side and subtract 1 from this side. And now I'm back to just y equals, which is what I want, x squared minus 2x plus 1. I'm going to leave that part, because that's my perfect square from completing the square, and make that plus 3. Hopefully you're starting to see what's going to happen here. Now we want to factor this trinomial. Two numbers that multiply to positive 1 and add to negative 2 is going to be negative 1 and negative 1. remember, when you do that completing the square, the number that shows up in the parentheses with x is always equal to what you got from half of b. Since I got a -1 from half of b, it's going to be x minus 1 in my parentheses. So this factored to x minus 1, shorthand way of writing it is right here. This is what the question asks us for, but your homework is going to ask for a couple of other things. It's going to ask us where is the vertex. Remember, it was x minus h, so in this case h is 1, and then plus k, so k is 3. So that's the ordered pair of my vertex right there. It's also going to ask us for the axis of symmetry. Remember, the axis of symmetry is that vertical line that goes through the vertex. A vertical line is always x equals a number, and if it goes through the vertex, it's always x equals the x-coordinate, x equals 1. So this is what it's asking for in this example, but because I know what your homework is, it's just nice to include that in there. All right, our next example. This one is here because every once in a while you're going to have a quadratic where b is equal to 0. We don't have an bx term at all. It's not there because b is 0. When b is 0, we can always just write for the number that the a, we'll write that down, and then in parentheses it's going to be x minus 0 squared minus 8. If b is 0, the x-coordinate of your vertex is going to be 0. We could check that by doing our opposite of b over 2a like we did in sections 1 and 2. But this is just a shortcut for you. If b is 0, you just put parentheses and write x minus 0 squared. Because remember, x minus 0, we can do that. That's just x. X minus 0 is just x, so we have 4x squared minus 8. And now, since there's only one thing in the parentheses, there's really no need for them, so we could just write it as 4x squared minus 8, and we're right back to where we were. But this is how you want to write it for vertex form, okay? So y equals 4 times x minus 0 squared minus 8. In this case, our vertex would be 0, -8. That's the ordered pair for our vertex. The axis of symmetry would then be the vertical line x equals the x-coordinate, so x equals 0. Just to give another example of something where b is 0, just make something up, y equals, how about a negative, and how about a fraction? So y equals -1/2 x squared plus, 7. It's my favorite number. All right, again, b is 0. So as soon as I see that b is 0, I'm going to do my x minus 0 in parentheses squared. Put the -1/2 in front and the plus 7. My vertex would be 0, 7. My axis of symmetry would be x equals 0. Anytime b is 0, it's going to look like that. And I know you have at least one on your worksheet like that. All right, now let's work through one where we're completing the square when a is something other than 1. Here a is not 1. In this case, it's -3. And b, there's a non-zero b. We have that x term here. When we did completing the square before, we had to have a be 1, and we still have to have a as 1 in these problems. Before, we would have divided everything by that -3 to get rid of it, and we're going to do something similar in this problem, but it's going to work out quite a bit nicer for the ones we'll give you here. So I'm going to start by y equals, rather than dividing everything by -3, since I'm only working with this ax squared bx part, these have a common factor. I can, rather than dividing by -3, I can just factor out a -3. So factor out the -3 there, -18, factored out a -3 will be positive 6x. Leave some room because I'm going to complete the square. Put my plus 10. Okay, so I only factored it out of these two terms, so they're the only ones in the parenthesis. I left the 10 alone. Now I'm going to do my completing the square. B is 6, 6 over 2 is 3, 3 squared is 9, so I'm going to add 9 here. Okay, so I've added 9, but that 9 is inside of this parentheses. So I haven't actually added 9 to this side. If I distribute that -3, I have actually added in a -27. Since if I distribute that -3, I get -27. That is what I've added to this side of the equation. If I add a -27 over here, I would have to again add a -27 to this side, but we want to get y all by itself. So to get rid of this -27, I'd add 27 here, add 27 here. And now I have, just writing it down here, y equals -3 times x squared plus 6x plus 9 plus 37. Now this part here in the parentheses is again a perfect square trinomial. That's the whole point of this. This can be factored to x plus 3, x plus 3. The thing in the parentheses with x is always what you got from half of b, +3, so +3. Everything else is still there. So that is my equation in vertex form. My vertex would be -3, 37. The ordered pair -3, 37. That's my vertex. My axis of symmetry is always x equals the x-coordinate of that vertex, so x equals -3. There we go. So there's the thing they ask for, but your homework will again also ask for this information there. So that's why I'm providing it for you. This one is back to one of our easy ones. A is 1, so I can just group these together and do y equals x squared plus 6x. Half of 6 is 3. 3 squared is 9, so I add 9. And then my plus 5 is hanging out at the end. This is my perfect square trinomial. Y equals x plus 3 quantity squared plus 5. What did we forget? We added 9 in here, so that means we had to add 9 to this side, subtract 9, that should not be a plus 5. 5 minus 9 is a -4. You need to make sure, that is the most common mistake on these, is people forgetting that if you add that 9 here, you have to add 9 to the other side, or really, from now on, I'm just going to say whatever I add in here, I'm going to subtract from out here, because I want to keep y by itself. So here's another example where we have an a that's not 1, so we're still going to just look at that part right there. I'm going to factor out a -3. -3 times, that leaves me with x squared, -18, factor out -3 is a positive 6x, leave some room, plus 4. Half of 6 is 3, 3 squared is 9, so I add 9. If I add 9 here, because of this -3, remember it's going to be distributed to it, I have actually added a -27. I've really subtracted 27 at this point. So I could put a plus -27 here, but then I add it, so I add 27. This can be factored to y equals -3 times x plus 3 quantity squared plus 31. -3 times x plus 3 squared plus 31. There you go. The vertex here is -3, 31. Our axis of symmetry is x equals -3. All right. I'm going to do an extra example for you. This extra example is a problem that is right off of your homework assignment. Just another one where a is not 1. So I'm going to flip this over and do it on the back. It's not in there. So this is problem number 5 from your worksheet. It says y equals 2x squared plus 12x plus 18. So that's number 5 right off of your homework assignment. We're looking at this. A isn't 1, so I'm going to factor out whatever a is. In this case, it's a 2. So x squared plus 6x, leave some room, close my parentheses, and my plus 18 hangs out afterwards. Half of 6 is 3, 3 squared is 9, so I add 9 here. I've added 9, but I've actually added 2 times 9. I added 18 here. So that means if I add 18 to this side, I would have had to have added 18 to this side. To get it back over here, I really want to subtract 18. So I get y equals 2 times x squared plus 6x plus 9 not equals, 18 minus 18 is plus 0. The plus 0 doesn't have to be there, but we'll talk about why it might be beneficial for you to keep it there. So I factor this out. This factors to x plus 3, and then if you want to put the plus 0, you can. I'm going to write it right now without the plus 0 in this case. So here's our equation in vertex form. Now to find the vertex, it's the opposite of what I see here, so negative 3 plus whatever I see here. I don't see anything, so it has to be a 0. But that might be a reason why you want to add in that plus 0, so that way you remind yourself that that is what is being added at the end. So there's our vertex, and our axis of symmetry is x equals the x-coordinate, so x equals negative 3. So there's a free one from your homework. Number 5, you got it done. All right, these notes right here, you can find these in your book. Obviously, you can find them here. You can find them on Canvas. But we've already talked about what's going on here when we did absolute value transformations and also in here, so I'll just briefly go over it. Whatever you see inside the grouping symbol, in this case the H is the thing that's in the grouping symbol, inside our grouping symbol always moves it horizontally, left and right, and it always moves it the opposite direction of what you think. Inside the grouping symbol is horizontal and the opposite of what you think. In this one, whatever is outside of the grouping symbol, K is outside the grouping symbol. Outside the grouping symbol added is always going to move it vertically up and down. Whatever is outside of the grouping symbol added or subtracted moves it vertically, and it moves it exactly the way you think it will. So if you see plus 4, you move it up 4. If you see minus 4, you move it down 4. All right. A, the number that's in front of those parentheses, the A value, that's just going to determine whether it opens up or if it opens down. If A is positive, it opens upward. If A is negative, it opens down. A lot of the examples that we've done so far look kind of like this, x minus, I'll just make up a number, something like that, and you don't see an A value here. If you don't see an A value, there's no number in front of the parentheses, that means it's a 1, it's just invisible. So that one would open upward. We're not going to talk about graphing these in terms of dilation. We're instead going to use this shortcut right here. So a shortcut for graphing in vertex form, the first step is plot the vertex. Draw that ordered pair, make a dot. Done. All right, have an ordered pair, have a dot. After you have that vertex, you will move one place to the left and then move vertically 1A, or just A units. Whatever A, the number in front of that parentheses is, that's how far up or down you're going to move. If it's negative, that's why you move down. If it's positive, you move up. So move one to the left and move A units. And then you also move one place to the right and go A units. It works if you go one to the left and right and move the same amount because these parabolas are symmetric. Then, after you've made those 2 dots, you now have 3 dots. We can get 2 more by moving 2 places from the vertex. This is 2 from the vertex. Move 2 places to the left of the vertex, and then you go up or down, depending if A is positive or negative, 4A units. So you go to the left 2, and then 4A units vertically. Make a dot. Move 2 places to the right of the vertex, and move 4A places vertically. This one here, we're not actually going to draw this on our graph because it's usually going to be too far away that it goes off the graph. But just to help us try to find a pattern, if you move 3 places from the vertex to the left, you would need to move 9A units. If you moved 3 places to the right, you would go 9A units as well. Notice you went 1 over and 1a, you went 2 over and 2a, you went 1 over and 1a, 2 over and 4a, and then 3 over and 9a. That's because these are squareds, these are quadratics, they have that squared in it. So if you move 1, 1 squared is 1. If you move 2 over, 2 squared is 4. If you move 3 over, 3 squared is 9. So for the examples that we're going to do here, we're only actually going to do this 3-step process right here. Plot the vertex, move over 1 each direction from there, and go up a units, plot a point. Move 2 each direction from the vertex and go 4a, plot a point. We have 5 points, draw on our parabola. All right, so this is one matching. The first thing we need to do is just find where our vertex is, and it's this point right here. So that's our vertex. It's the ordered pair 2, -3. So if it's 2, -3, it needs to be x minus 2. Remember, it's always the opposite of what you see, squared, minus 3. Opposite of what you think it should be in here, and exactly what you think it should be right there. So -2, -3. So -2, that's not -3, -2, -3, that one's still in. -2, that's not -3, so C's out, -2, -3. So now we're down to B and D. Remember, if we move over 1, we should go up a unit. So from my vertex, if I go over 1, I went up about a half. So I need to have a of about a half. Definitely not 2, here's of a half. If I went 1 over this way, I went up half, so 1/2. If I went over 2, I went up 1, 2. So I've gone up 4a is equal to 2. Divide both sides by 4. A is equal to 1/2. 1/2 right there. All right, here is actually graphing one. First, we need to write this in our vertex form. So I'm going to do y equals, factor out my -2, x squared minus 2x, leave some room, plus 1. I'm going to do half of -2. -2 over 2 is -1. -1 squared is 1. So I'm going to add 1 right here. I put plus 1 here, but what I've actually added in is a -2. -2 times 1 is -2. So I've put in a -2, which means to get rid of that -2 I've added here, I need to put in a +2. -2, +2 cancel each other out. So now I can write this as y equals -2 times this factors to x minus 1 squared. Remember, this is a -1, so -1 in my parentheses, and 1 plus 2 is 3. So here's my equation in vertex form. My vertex is at the ordered pair 1, 3, opposite of what you see, exactly what you see. So I go over 1, 1, 2, 3. There's my vertex. Since A is negative, it's going to be opening downward. But from my vertex, I go over 1, and then I move A units vertically, so -2. So over 1, down 2, make a dot. It's symmetric, so I can go over 1 the other direction, and down 2, and make a dot. Over 1, down 2, over 1 the other way, down 2. Because the reason why it's 2 is because A is 2. Now I can go 2 away from my vertex and move 4 times A, which is -8. So from my vertex, go 2 to the left and go down 1, 2, 3, 4, 5, 6, 7, 8, and make a dot. I can go the other direction, move 1, 2 from the vertex. 2 squared is 4, so I do 4 times A. 4 times -2 is -8, so I go down 8 places, and I make a dot. And I've got my parabola. This one here, one more. Our vertex is at -1, 2. If it's -1, 2, I have x plus 1 squared plus 2. So plus 1 plus 2, this is the only one. I do go over 1 and down 1, 2, 3, over 1, down 1, 2, 3, so A should be -3 as well, so it all works out. For the sake of time, I'm just going to skip that one One last example here, and there will be 2 like this on your homework, and the SAT and ACT love to ask you this type of question. It says write an equation that has a vertex of 4, -8. So let's start out with y equals a times x minus the x-coordinate squared plus -8 or minus 8. So I have everything except for a. How am I going to solve for a? I don't know. Well, what other information did they give us? An ordered pair. So let's take that ordered pair, plug it in for x and y, and we can solve for a. So we have -2, the y-coordinate, is equal to a times x is -6. Start that again. -2 is equal to a times -6 minus 4 squared minus 8. -6 minus 4 is -10. Add 8 to both sides. Gives me 6 is equal to a times -10 squared. -10 times -10 is 100. So I have 6 equals 100a. Divide by 100, and I have 3/50 is equal to a. Now that I know what my a value is, I can take that, put it in right there, and give my final answer of y equals 3/50 times x minus 4 squared minus 8. So just plug in the vertex for h and k, plug in the ordered pair for x and y, solve for a, and then rewrite your equation. All right, last slide here is your homework. It's a worksheet. I will upload a PDF of the worksheet. If you have a printer, you're welcome to print it out and do it right on the worksheet. If you don't, you're welcome to just look at the questions and do it on your notebook paper. That's perfectly fine. Whichever method that you choose, you don't actually have to do all of the problems from the worksheet. You don't have to do numbers 3, 6, or 9, just for not having too many questions. So 3, 6, and 9, you get to skip those. Remember, we did number 5 already for you. This worksheet will be due on Tuesday, but I recommend you practice this tonight because Friday is a review and Monday and Tuesday we're taking a test. And some of this material, there's going to be a few questions over these on that test. So you want to make sure you have done it before. Monday's test, Monday's part won't have this. This will come till Tuesday. So if you have some questions, you'll be all right. We'll talk more about what's on each part of the test on Friday. If you have any questions, please let me know. Have a great day.